Hey there, class. Mrs. Matheson here. We are going to start Unit 7, and our first notes are going to be on circles and circumference. Our learning targets today is I can identify parts of a circle and solve problems using the circumference of a circle. So we're going to go a whole new direction here, and we're going to start talking about circles. So let's just talk about, well, what is a circle? A circle is the locus, or a set of all points in a plane equidistant from the given point called the center. All right, set of points is what a locus is. And then equidistant means it's all the same distance from the center. So we have that picture there on the right-hand side. And our circle is always going to be named by its center point. And so we're going to draw a circle and put a point and put C. Or we can write out the word circle, C. All right, let's talk about a radius. It's a segment with endpoints at the center and at the or on the circle. Okay, so an example here would be CF is a radius. We also could say CE is a radius. And we also can say CD is a radius. So it's only from the center to the edge. When we have what's called a chord, it has segments. It's a segment with endpoints on the circle. So a chord doesn't have to go through the center like we could have AB. That's a chord. We also have DE, and that just happens to go through the center, and so that's going to be the diameter, which is a special chord. All right, the diameter is a segment with endpoints on the circle, just like a chord, that passes through the center. And it's made up of two radii. So DE is our diameter. And when it talks about being made up of two radii, that's plural for radius, we have CD and we have CE. So those are two radii. All right, so let's just identify parts of a circle. Let's do A together. The name, remember, is based on that center point. So we're going to say circle P. Make sure you put that dot in the middle there. Radius. Well, I see three radii here. We have PL, we have PM, and we have PN. All right, our diameter needs to go all the way across, so that's going to be our LN. Don't forget these are segments, so we're putting segment bars above them. All right, and then we're going to name a chord. And a chord has endpoints on the edge, so we could say MN, or we could even put in there LN, which is that special chord of a diameter. Okay, I want you guys to try B out on your own. Just follow what we did for A. All right, 2 says, if QV equals 4, what's the diameter of circle Q? Well, QV here is a radius. When you remember, the diameter is 2 radii. So we're going to take 2 times 4. So our diameter is 8. Number 3 says, if TU is 14 feet, so let's just mark TU, that's this whole distance here, is 14 feet. What's the radius of the circle Q? Well, TU looks like it's the diameter because it goes through the center. And so we know the diameter is 2 radii. So we can take 14 and divide by 2. Then we get 7 feet for our radius. Not too terribly bad for those first few ones. Okay, let's talk about pairs of circles. We have two different types of pairs. We have congruent circles, so that means that the radii are congruent. So, since GH is congruent to JK, then circle G is congruent to circle J. Because their radius is going to go all the way around, so that means their whole circle is going to be congruent. Okay, so we have also called concentric circles. They're coplanar circles that have the same center, but you'll notice their radii are different distances. So we would call them both circle A. Let's look at our smaller one. Circle A has a radius of AB. But then we have circle A, which is our larger circle, And that is going to be a radius of AC. So same circle, center, but different circles. So sometimes we have these circles that intersect. In our first picture, we see 2 points of intersection. In the middle, we only have 1 point of intersection. And then in the last picture, we actually have no points of intersection. All right. So using that idea of intersection, let's look at these next couple of problems. Problem 4 says the diameter of the circle S is 30 units, the diameter of circle R is 20 units, and DS is 9 units. Find CD. Okay, so sometimes it's easier for me if I draw it out bigger, just so that I don't worry about overlap. So I have R, C, D, oops, point there, and S. So let's start with, it has a diameter of circle S is 30. So that means from S to C is a radius, and that's 15. The diameter of circle R is 20. So R to D is going to be 20. We want to know that we know that DS is 9. So we want to find CD. Okay, so actually in this picture I'm not even really going to use the 20. Oh, that should be a 10, sorry, for radius 10. I'm not actually going to use that. I'm going to use what I see right here. So the whole thing is 15, and if I subtract out the part of it that's 9, I should be able to get my leftover. So my CD is equal to 6. All right, let's try that again with this problem here. It says the diameter of circle X is 22, and the diameter of circle Y is 16, and WZ is 5. Find XY. So this time we're looking for the whole distance. So let's fill in what we've got here. So we've got X with W, Z, and Y. The diameter of circle X, so X to Z, the diameter is 22, so this is a radius of 11. The diameter of circle Y is 16, so Y to W is going to be 16. And WZ is 5. I want XY, so I want the whole thing. All right, I want you guys to think of, you can come up with how long that distance is for the whole thing. So I've drawn it out for you. You need to come up with that distance and see how you do with that. All right, so then that brings us to circumference. And actually, I think this is a good place that we're going to stop our video. And we'll talk all about circumference in class. It should be something you've kind of seen before. And I'll tell you this, it uses that funny symbol called pi. So we'll see you guys then.